Hello everyone, it's August 17th. I forgot to change the title. Alright, August 17th. This should be a medium question. Let me change the title first. Alright, let's go for it. What do we have? Count good nodes in a binary tree. Okay, we like trees. We like binary trees. Given a binary tree, a node is good if the path from root to x, there are no nodes with a value greater than x. Return the number of good nodes. So 4 good nodes. Nodes in blue are good. So the root is always good, right? Because the path from a root to x, there's no other nodes. So yeah, there's no other nodes with value greater, okay? So 3 is good. And then for each node, we have to check the path. So this one, 3 is in the path, this is not good. But this 3 is good because in this path, no nodes have value greater. This one's good, this one's good, but this is not good because these are all greater. It's always a good node, okay? 4 is the max value in the path. So we just need to find which nodes is the max value in the path. And these are all max value in the path. Okay, number, value. Yeah, I think that's the trick, right? Just we're gonna do DFS, and as we do DFS, we always keep track on the max value during the traversal, all right? And then when we hit a new node, we check if that node's value is larger or equal to the max value so far. If it is, that is a good node, right? If it is not, that's a bad node. But we just keep going, and then we pushing. I feel like that is the case, right? That's not. I don't see anything more than that. Okay, let's take a look. All right. So what we do is just a DFS. That should be straightforward. And we don't have test case today because it's tree. We have this. Okay, so DFS, node, and yeah, we don't return anything. I don't need to return anything. How about the count? Well, the count is easy. We just need to do self dot res equals 0, right? And then, we do need a max though. So current max can be an int, right? So we say if not node, return, right? Now if node, we're gonna check if node.val is larger or equal to current max self.res plus equal 1. Current max equals node.val. And we DFS node current max. So we keep doing this. No, node.left and DFS node.right current max. So left and right. And we just do DFS root current max. Current max should be root.val. What if there's no root? There always is a root. So root.val comes in as larger or equal to yes, so we get +1, and return self.res. Okay, let's try it. Try to test the case. 4. Okay, so how about this one? Okay, this one, 3. Okay, how about edge case? That is a 1. All right, let's try it. Submit. Pending. Accepted. Okay, we're done. So simple DFS suffices. We keep track of the max value in each DFS path. If the current node is larger or equal to the max, record increment the result and update the max value. On because each node is visible once, and runtime, what's the runtime? Times 232 milliseconds, which give us an 89% ranking. Okay. All right, let's go back to the problem and take a look. It's what, 1,448. Well, this should be labeled an easy question actually. 1,448. Yeah, that's what it is. 1448. Is there any trick? Pre-order. Simple DFS. Yep, I think that's about it. Nothing too fancy. Oh, filter. Uh-huh. Good notes child. Oh, I think it's trying to do. Wait, filter. What does filter do? What does filter do? Actually, I don't know. The filter function. What does the filter function do? Filter the array or to a new array with only the values equal to or above 18. Filter, we put a function and we put ages. I don't understand. So filter none and root out left and root out right. None means the function is none. Filter none. What the hell is filter none? It's a function iterable to be run, and the function is none. What does a none function do? Hold on. Filter none. What is this? Removing none values. Oh, I think is it removing none values from a list? Maybe it is using list comprehension. Using filter. Yeah. Checks for any none value in list and removes them and form a filter list without them. Oh, I think if you don't offer a value, then you just do equal, right? Filter out a value that's equal to this. I think that's, I need to read the documentation. Python filter documentation. It's a built-in function, yeah. Where? Filter, F here. Return a float. No, here, it's a float. Construct an iterator from those elements of iterable, for which functions return true. construct interval from those elements for which this one returns true. Iterable may be either a sequence, container, blah, blah, blah. If function is none, the identity function is assumed. That is, all elements of iterable that are false are removed. So if it's none, then we have an identity function. Identity function. So, I see. The identity function assumes that is all elements of iterable that are false are removed. Oh yeah, nice. Learn something new. So this filter is filter out when obtain all the true values, right? Just if a root is at the leaf level, so nothing will come out. Okay, that means we don't keep going. But we always do self count plus 1. Okay, this is good. So the child, so we look at the child, right? And then why the self dot count plus 1? Shouldn't be, we have a root, right? And we'll look at the children. And for each children, if we have a value is larger than my root value, I do this. And child.val, or I'm changing the value of each child. I don't know how I feel about this. I don't know how I feel about this, man. No, I don't like it. I like the use of filter, right, to filter out the none, right, the none values, but I don't like the fact that the values in the original tree is modified. I don't like that. Values are modified. Yeah. And I honestly, this logic is, so yeah, we just keep it in the child.val. So each child.val is the current max, right? Which does make sense. We do all this, and oh, I see. This one is not used. We all keep tracking on self.count, and this is just for returning purpose. I see. But still, I don't. Yeah. Yep. Yeah, I mean, that's it. It's nothing too fancy. All right. I will see you guys tomorrow. Adios.